The memory of water is long. It carves canyons, drowns continents, and whispers secrets in the language of tides. But in the high, thin air of the Peruvian Andes, where glaciers are retreating at a pace visible in a human lifetime, water holds a more immediate, more urgent memory. It remembers the ice. And as the ice vanishes, so too does a library of ancient knowledge, a chronicle of civilizations, and a fragile equilibrium that has sustained life for millennia. My journey began in the clamor of Lima, a city of 10 million souls clinging to a desert coastline, and ended in the silent, awe-inspiring expanse of the Quelccaya ice cap, the largest glaciated area in the tropics. It is a journey from thirst to source, from the complex human systems built on a promise of water, to the stark, beautiful, and diminishing source of that promise itself. Lima is a paradox. A mega-city in one of the world's driest deserts, receiving less than an inch of rain per year. Its lifeblood is the Rio Remits, a thin, braided stream of silty water tumbling down from the Andes. From my hotel window in the district of Miraflores, the Pacific Ocean stretched, immense and undrinkable, to the horizon. Below, the city hummed, watered by a miraculous and precarious feat of engineering and history. The Inca, and later the Spanish, built canals to channel Andean snowmelt. Today, a complex network of reservoirs, tunnels, and treatment plants performs a daily miracle of hydration. Yet, in the city's pueblos jóvenes, the hillside shantytowns, the tap is often dry. Water arrives in trucks, a commodity sold by the liter. The inequality of access is palpable, the anxiety of scarcity, a constant undercurrent. My guide into this world of hydraulic tension was Elena Correa, a hydrological engineer with Lima's Water Authority. "We are a city that lives in the future tense," she told me as we drove along the Rio, its banks lined with concrete to prevent flooding in the rare event of a true downpour. "Our water supply depends on what happens 15,000 feet above us, and 6 months ahead of us. The rainy season fills the reservoirs, and the glacial melt sustains us through the dry season. It is a natural buffer, a bank account of ice. But that account is being depleted." She showed me graphs tracking the retreat of key glaciers in the Cordillera Blanca, hundreds of miles to the north. The trend lines were precipitous, falling like cliffs. "When the buffer is gone," she said, her voice quiet but firm, "Lima faces a permanent dry season." But Lima is only the most populous node in a vast, thirsty system. To understand the source, I had to follow the water upstream, into the heart of the Andes. I joined an expedition led by Dr. Mateo Flores, a glaciologist from the University of Cusco. Our destination was the Quelccaya ice cap, a sprawling, 17-square-mile frozen plateau southeast of Cusco. We loaded a caravan of 4x4 trucks with gear, ice cores, drills, drones, spectral imaging equipment, and enough quinoa and dried potatoes to last a month. The team was a blend of seasoned Quechua porters, their faces etched by wind and sun, and young Peruvian scientists, fluent in both satellite data and the Quechua names for every peak and stream. The road climbed relentlessly out of the Sacred Valley, leaving behind the tourist bustle of Cusco. Eucalyptus gave way to hardy ichu grass. Adobe villages with terracotta roofs became scattered stone herders' huts. Llamas and alpacas, adorned with colorful tassels, regarded us with aristocratic indifference. The air grew thin and cold. At a pass of 14,500 feet, we stopped to offer coca leaves to the apis, the mountain spirits, a ritual led by our head porter, Romualdo. "We ask for safe passage," he murmured in Quechua, his hands casting the leaves. To the wind. "The mountains are not just rock and ice. They are alive. They give water, they can also take life." For Romualdo and his community, the retreat of the glaciers is not merely an environmental data point, it is a physical withering of a sacred body, a retreat of the divine. After 2 days of driving and a final, grueling day on foot, we arrived at base camp on the moraine of Quelccaya. The sight was simultaneously majestic and melancholic. Before us lay a vast, undulating field of ice, gleaming under the intense alpine sun. It was breathtaking, but Mateo immediately pointed to the dark, rocky lines along its edges, the morolines, the glacial scars. "See here," he said, tracing a line on a satellite photo and then pointing to a corresponding ridge of bare rock several hundred meters from the current ice edge. This was the ice margin in the 1970s, when my mentors first came here. It has retreated over a kilometer since then. The pace is accelerating. Our days fell into a rhythm dictated by the sun and the weather. At dawn, we would rise in the freezing tents, brew strong coffee, and plan the day's work. Mateo's team would drill for ice cores, extracting slender cylinders of ancient ice that contained trapped air bubbles, volcanic ash, and pollen, a frozen archive of Earth's climate. Each layer was a year, a snowfall from centuries past. This ice, Mateo explained, holding a core section that glowed with a faint blue light, may contain records of the rise and fall of the Tiwanaku Empire, or the droughts that may have stressed the Inca. It is history, written in water molecules. My task was to accompany the mapping team. We flew drones over the ice cap's edge, documenting the intricate network of meltwater lakes that had formed on its surface. These supraglacial lakes, brilliant turquoise jewels against the white ice, were both beautiful and ominous. They are accelerants, said Sophia, a young geomorphologist. The dark water absorbs more solar heat than reflective ice, melting it faster. And if the lake drains suddenly, it can cause catastrophic flooding downstream. She showed me images of huaicos, the devastating mudslides that periodically scourge Andean valleys, often triggered by just such glacial lake outburst floods. One afternoon, I hiked with Romualdo away from the scientific camp, toward a lower valley where his community still maintained seasonal grazing grounds. The landscape here told a different story of change. We passed an old, dry stone corral that was now miles from any reliable water source. When my father was a boy, the glacier's tongue reached almost to this valley, Romualdo said. The stream was strong, and this pasture was green all year. Now, the stream is seasonal. The grass is poorer. We have to take the herds higher, but there is less land up there. He pointed to new, unfamiliar flowers pushing through the ICHU. These plants, they come from lower, warmer places. They are moving up as the warmth moves up. This vertical migration of ecosystems is one of the most visible impacts of climate change in the tropics. As the thermal belt shifts upward, species adapted to cold are squeezed toward the peaks until they have nowhere left to go. The Quechua farmers and herders, with their deep, generational knowledge of microclimates and planting seasons, find their ancestral knowledge suddenly out of sync. The rains are less predictable, frosts come at the wrong time. The Apis, the ice-bound mountain gods, are seemingly withdrawing their favor. Back at the ice cap, Mateo summoned us to his tent one evening. His face was grim. A radio call had brought news from the Cordillera Blanca. A large glacial lake had partially drained, causing a huaico that washed away a small hydroelectric plant and buried several hectares of farmland. Thankfully, early warnings had prevented loss of life, but the destruction was severe. This is the new normal, Mateo sighed. First, we have too much water, floods, outbursts. Then, as the glacier disappears, we have too little. It is a crisis of both scarcity and inundation. The event hundreds of miles away cast a pall over our camp. It was a stark reminder that the data points we were collecting, millimeter changes in ice thickness, parts per million of carbon dioxide in ancient bubbles, had direct, violent consequences in the lives of people downstream. The memory locked in this ice was not just about the past, it was a grim forecast. A few days later, I joined Mateo on a traverse to the ice cap's summit dome, at over 18,000 feet. The climb was arduous, every step in the thin air required conscious effort. The world narrowed to the crunch of crampons on ice, the heave of my own breath, and the blinding whiteness. Finally, we reached a broad, gentle rise, the top of the world in this region. The view was staggering. To the east, the Amazon basin stretched in an infinite green carpet, the source of moisture that falls here is snow. To the west, the sharp ridges of the Andes fell away toward the desert coast. We were standing on the continental divide, a fulcrum between two worlds. Mateo knelt and began setting up a delicate instrument to measure surface melt. This ice cap, he said, gesturing around him, is a sentinel. Because it is in the tropics, it responds quickly and dramatically to changes in global climate. It has no seasonal buffer like the polar regions. What happens here is a hypersensitive signal of what is happening to the entire planet. He paused, looking out at the expanse. We are not just losing glaciers. We are losing a climate recorder, a water regulator, and a cultural icon. When this is gone, he said, patting the ice, it is gone for good. There is no coming back from rain at this altitude. His words hung in the thin air. The silence up there was profound, broken only by the constant wind. I thought of Lima's sprawling thirst, of Romualdo's shrinking pastures, of the turquoise melt lakes that were both mesmerizing and menacing. The connections were visceral, a hydrological thread tying the ice beneath my feet to the faucets, farms, and floods thousands of feet below. This was the heart of the water cycle, and it was beating erratically. Our descent from Cuelcaya was a journey back into the realm of human adaptation. In Cusco, I visited a project reviving ancient Inca water management techniques. Before a fascinated group of engineers and farmers, a hydrologist named Carlos explained the concept of cachas, networks of small, interconnected reservoirs and infiltration ponds in the highlands, and amunas, pre-Inca canals that divert water during the rainy season to let it seep into the ground and resurface months later, downslope. We call it slow water, Carlos said. Instead of letting rainwater and meltwater rush down to the sea, we slow it down, spread it out, let it sink in. It's a way of mimicking the natural buffer that the glaciers once provided. It was a powerful idea, fighting the future not only with advanced technology, but with ancient wisdom. It represented a hybrid vigor, a blending of millennia of observation with modern understanding. On a mountainside outside the city, I saw a community rebuilding an amuna. It was hard, manual labor, moving stones and earth, guided by elders who remembered fragments of the old ways. It was an act of hope, a literal grounding of water in the landscape. My final stop was back in Lima, but not in the bustling city center. I went to the outskirts, where a community had painted a massive mural on a reservoir wall. It depicted the Apis' wise, weeping faces, their tears becoming rivers that flowed through terraced farms and into the city. Alongside it, engineers were installing a new, German-made fog catcher system, vast, vertical nets that capture moisture from Lima's persistent coastal fog, providing a supplementary water source for the neighborhood. Standing before that mural, the story came full circle. From the sacred ice of the Apis to the high-tech fog nets, the narrative was one of profound interdependence and urgent innovation. The memory of water is indeed long, but human memory is short. We forget that our civilizations are built on climatic stability. The Andes, with its retreating glaciers, is a stark reminder. The ice holds a memory of the past, and in its rapid disappearance, it offers an undeniable portrait of our present and a daunting question for our future. The Cuelcaya ice cap will likely be gone for our children, a memory itself. The challenge for Peru, and for the world, is to learn the lessons it holds before it vanishes, to listen to the whispers of the past in the ice cores, to heed the warnings in the growing melt lakes, and to combine the oldest wisdom with the newest science to forge a new relationship with water. For in the end, the story of these mountains is not just a story of loss. It is a story of resilience, a testament to the human capacity to adapt, and a crucial chapter in the unfolding story of our planet's changing climate. The water remembers. The question is, will we?